Hello, everyone. I'm Ryan Luther, co-founder and CTO of OneTalker Innovations. Today, I'm going to talk to you about the Osmosis suite of products that OneTalker Innovation has to offer and how we are integrating those products in with Advantech hardware and specifically doing a demo for the U.S. Air Force and DoD at large. So OneTalker Innovations is a small disabled veteran-owned company. It's that background that gave us the idea to create a network that is agnostic to what kind of protocol you want to speak or what spectrum you want to speak in. We allow devices to connect directly to each other and cut across existing networks and remain able to communicate. So Osmosis is software-based. So with a software download, you can download into devices, turning devices into routers and cell towers, if you will, allowing them to communicate directly. This is really important with the current data use rate that everybody's trying to get more and more data. So data use is exponentially increasing and infrastructure is not. So this allows with software to turn existing devices that are already out in the field into infrastructure, providing the superstructure of devices and connectivity to keep up with the demand. So there's a few pillars that we wanted to build into Osmosis, and I'll go through them here. One is multispectral capability. We wanted to be able to both communicate in low frequencies to get long range and good throughput through balsam foliage, as well as communicate in very high frequencies to get very high data rates, as well as high precision when it comes to autonomy and data fusion and things of that nature. So we built it to scale between all the way from IoT and 5G. And if you think about 5G with millimeter wave, very high frequencies, very short transmit distance. So when you create a network like ours that allows a whole bunch of devices to make short range connections, you empower that 5G by creating a lot of short range communications to create that 5G infrastructure. The next thing was multi-level security. We knew we wanted to build this to both support government and commercial operations, and the only way to do that was having multiple levels of security. So you can create security groups, you can encrypt it with different methodologies to support HIPAA banking, law enforcement, DoD operations, et cetera, and have those interoperable across those agencies to maintain connectivity throughout the network in one overarching infrastructure. So that infrastructure is really important, and we wanted to build it as open as we could. So all of our code is very modular in design. It's designed to use our network messaging to encapsulate a transport or a payload. And that payload could be any spectrum that you want to speak in. It could be any protocol language, and it can be any encryption schema that you need for your particular operation. So we built it open, and then we built it to scale. So when devices register based on their capabilities, they enter into the hierarchy based on the performance of them in real time in the environment. That hierarchy gets adjusted, and it allows the network to not overload any lesser devices and put more of the load of the network operations on larger, more capable devices, allowing it to scale in a global fashion, which ultimately all creates seamless connectivity anywhere in the world and anytime you want it. So this next slideshow here is just showing that if you got devices in these various locations and you're trying to transmit between the location of A and across to the right, the location K, that these devices will self-discover each other, enter into the network securely, start communicating with those communications, determine a best path. Each individual node is determining what its best path is through the network, basically eliminating the lesser paths, choosing the best path. And in this instance, that's across 6 nodes. We have about half millisecond latency on each connection. So this is about a 3 millisecond connection right here, and it's done securely, and it can be done off-grid or extending an existing network. So once we built the network, we realized that we needed to be able to plan it, because if you have if you have devices out in the field that are making the infrastructure, many of those are going to be mobile and be moving around in three-dimensional time and space. And so having the ability to put those performance characteristics in, model it with environmental effects and RF propagation loss, and really define what your performance and what your coverage of your network is going to be is really important. And that's what Osmosis Planner does for you. So it allows you in a smart city situation to go, hey, based off the past month of traffic patterns, this is actually the performance I'm going to get, and then assess if you need fixed infrastructure to go beyond that mobile infrastructure, and where you need those fixed pieces to be. This is a demonstration of Osmosis Planner. This is in the aviation setting, and we also have satellites in the simulation as well. In red, you can see two jammers in two different spectrums. The lines in red are the effects that they're having on the aircraft. The green lines are the connection paths, and you can see that they're dynamically changing and working around that jamming without any manual input by the user at all. It just uses that self-healing and load balancing nature of the routing to make the decisions to work around that jamming without any adverse effects. So the other product that we wanted to introduce to you is Osmosis Manager. So once you have everything planned, you need in real time a way to assess the actual performance based on what you planned to put out there. And so Osmosis Manager allows you to do that. It allows you to monitor the entire network as well as each device and get performance characteristics of each device, each connection, and the entire network itself. And then you can compare that against what was planned. And if there's any deviations from plan to actual, it can highlight that to the operator and to the network to take automated actions or manual actions to fix that. And it can be turned back into Planner so that every time you plan, Planner gets better and better and closer to what you actually need in a field. So for the demo that we're going to do with Advantech, we're going to have what you see on the screen, this Advantech product line. We're going to put that in a hangar, and we're going to connect the Sky server and the ARC gateway that you see on the right to the internet. The lines in blue indicate Ethernet connections. The gold lines indicate Wi-Fi connections. So basically, we're going to connect up and have two separate networks connected up via Ethernet, one through the Sky server and one through the ARC gateway. What we're going to do next is take that traditional infrastructure and we're going to disconnect the Sky server from the internet. This is going to force an osmosis path to get to the internet. So we're basically going to take the two independent networks, connect them together through Wi-Fi and through osmosis to show you that once disconnected, there's no impact to operations and no manual input for the user to take. And it's a seamless transition that the user would not be aware of if they didn't have a tool like Osmosis Manager to see that change. Next, we're going to start pulling some Ethernet cables from backhaul. So we'll pull it from the ARC gateway to the Trek 60. We're physically going to turn off the Sky gateway, and we're going to disconnect the lower Trek 60 to one of the 21-inch touchscreens. This is going to force more of the network over to Wi-Fi and just show that, again, there's a seamless transition to pulling that plug, no manual input to reconfigure those assets like you normally would have to do to fault over to the Wi-Fi. We're going to start turning more things off. So we're going to turn off both Trek 60s and show, okay, now we have a disconnected network where we basically just have end users at the end in the network. And then we're going to introduce the Jetson class, the SA60s, into the network and show, hey, these things are going to self-discover. They're going to enter the network securely, and they're going to take over where the Trek 60s got disconnected and reconnect the network up. And connect everything back through the internet through the ARC gateway. Next, we're going to disconnect the ARC gateway you see on the right-hand side from the internet, showing you that all of these devices will maintain connectivity and continue to operate off-grid. Finally, what we're going to do is take the Jetson server at the bottom and turn on the LTE and show that you can, through any of these devices, have an LTE or other path and have an alternate internet connectivity option, and show that all of the devices in the network reconnect to the internet seamlessly. So what I have here is some depictions of what we just discussed out in the field. So this is an operations center showing the 21-inch touchscreens as well as a laptop, and showing that they can provide connectivity with Osmosis Planner, Osmosis Manager, the network, and other operational pictures. This just shows out in the field. You can have Trek 60s, you can have SA 60s out there connecting aircraft, foot soldiers, laptops, and drones. And then in a commercial setting, you can have off-grid mobile devices connected up through SA 60s in an automotive sense, Trek 60s in light aircraft, sky servers in larger aircraft, and off the screen you can imagine this could connect up to maritime as well as space assets as well. And then this finally is a smart city concept where, again, all of those things in play to include a drone connecting up in a smart city infrastructure, providing those services. We know there's a lot of other SKUs, and we're really excited to be partnering with Advantech and showcasing our capabilities in your devices. And we have had some really good traction lately with being announced as one of the most fundable companies in America, as well as some of our work with telecommunication companies on the commercial side, and the multiple contracts that we've been awarded on the government side. So if you have any questions, please reach out to me. I really appreciate your time. Thank you very much.